From the very beginning of computers, people asked the question, can we make these machines perform tasks that seem to require intelligence or thinking? That enterprise of making smart machines has come to be called artificial intelligence, or AI. Artificial intelligence is omnipresent really in everything that we do. When we visit a hospital, it could well be monitored by AI algorithms, traffic algorithms run by AI that are assisting us in our route choices. When we are on the internet, almost everything we see is determined in part by AI algorithms, for good or ill.
If you want to think of like AI as a big group of algorithms, there's a subset of these algorithms that are called machine learning models. An algorithm is just a set of steps that a computer needs to follow. A learning algorithm is an algorithm that allows us to develop a machine learning model. Their goal is still to mimic human reasoning on some level, kind of present the algorithm with data. The algorithm then learns patterns that resemble how a human being made a specific decision. I work on developing causally motivated models, and what this means is that we build predictive models that kind of encode cause and effect relationships rather than maybe random associations that might happen. We're trying to develop machine learning models for risk adjustment for the purpose of like health insurance. We want these models to be robust. In some cases, health insurance companies will make their patients look a little bit sicker in ways so that they can sort of get more out of the government or get more reimbursement for these patients out of the government. So we wouldn't want our models to allow that.
My work is in natural language processing and specifically developing algorithms to enable embodied agents to communicate with humans in natural language. Natural language processing is about developing computational models for interpreting and generating human language. In my lab, we focus on grounding language to the physical world.
Hi, Tiago. Can you help me prepare my lunch?
No problem. And there is your sprite.
We use different kinds of context to help understand language, for example, physical context, situation context, and communicative context. Language is really kind of the glue, I think, connecting all these different processes together in AI. We really need to enable this robot to have the ability to continuously learn from humans, to learn from the environment. It's really an exciting time to study grounded language communication and develop embodied agents that can communicate with us and work with us.
When it comes to healthcare, I think that's another place where we can really see, in general, helping with diagnosis, helping with drug discovery, helping with how you train physicians, how you train patients, how you train families into taking care of somebody. Like, for instance, the work that I've been doing is more like in interacting with counselors and trying to help counselors get better at what they do by providing feedback on the counseling they do. If I'm counseling you, then after the fact, you will tell me, you asked this many questions, there were this many reflections, you spoke for so much, your client spoke for so much, so there will be feedback coming afterwards. I really think the right strategy will be to think of ways in which this AI can make us better and embrace it.